So what we'd like to do is simplify this rational expression, okay, and we'll approach it from looking at the numerator and then the denominator. So here goes. Can we factor out anything from each of the terms in the numerator? It turns out, yes, we could take out a 2, and we also could take out a v. Alright, so if we take a 2 from the first term, a v cubed is left, and if we take a v left, there's a v squared left. Alright, if we take a 2 from, so the minus sign, 2 from 22, we got an 11. You take a v from v squared, it leaves behind a v. If we take 2 from 20, it leaves you with 10, and take v, there's no other v left. And then in your denominator, you have a difference of squares, and we know how that goes. The signs are different. V times v would give you the v squared, and because the signs are different, you don't get any middle term, and the last two terms must be the same. So 10 times 10 is 100. Moving along, I have 2v, and then the question is, can I factor the numerator at all? And the answer is what? Let's see. V times v will give you v squared, and then we need the factors of 10 that add to 11. Well, 10 and 1 factor to be 10, and they can add to be 11. This being saying the signs have to be the same, and this saying both signs have to be negative. And what you end up with is that v minus 10 cancels with v minus 10, just like if you had 5 over 5. And the end result is you have 2 times v in the numerator times v minus 1 all over v plus 10. And that is your result. Let's attempt another one here. We want to factor the numerator, and we want to factor the denominator. So let's factor this one. Let's start with the numerator and then go to the denominator. So what can we factor out from each term? It looks like we might be able to get a 3 from each of the terms. So we get 3, and then we get a squared, plus 3 goes in that one time, remainder 1, 6a, plus, and then 3 times 45 gives you 135. So that's the numerator. For the denominator, we can factor out a 3. But you know what? Let's make it even a little quicker. Let's factor out a 3 and an a, because it looks like we can get both of those from all those terms. So we get a 3 times a. If we take a 3 from the first term, 1 is left as your coefficient, and then an a from the a cubed will leave you with a squared. So 3a times a squared gives you that. Plus 3 from 33 leaves you with 11. A from a squared leaves you with 1a, plus 3 from 90 leaves you with 3, 0, and you take an a, there's no other a left. If we factor the trinomials in the numerator and denominator, we'll get a times a will give me the a squared. Need factors of 45 that give you 16. Factors of 45 that give you 16. So what do we got? 9 times 5. Oh, I made a mistake. This should be 14. 3 goes into 12 4 times. So that's the kind of mistake that you can make while doing these kinds of problems. I mistakenly said 3 goes into 12 6 times, but 3 times 6 is 18. So that gives you a 4, and I could tell from doing this problem where the problem was, because what are the factors of 9? It's 9 and 5, but 9 and 5 are 14, and since both of those are positive, alright, so again, you'll make mistakes like that too. It's just a point of you need to be just as careful as I, and then finding the problems when you're done. So what are the factors of 15 that add to give you 11? Well, let's do the first two. A times A would give you A squared. What are the factors of 30? Well, you go 10 times 3. That won't work. How about 6 times 5? Well, 6 and 5 can add to be 11. Since both are positive, both will be positive. And we end up with this A plus 5 cancels this A plus 5, because we've got all multiplication going on between the factors. We have 1, 2, 3 factors. 1, 2, 3 factors. The 3 will cancel with the 3, give you the 1. And we are left with, in the numerator, A plus 9 divided by A times A plus 6. And that is completely factored and simplified.